All right, we're going to solve equations with fractions and decimals, but before we do that, we have to learn how to find the least common multiple, which is the same as the common denominator. I don't think I'll need to, because I think that you'll understand, I think.
Okay.
The common denominator, and I'm going to abbreviate, okay? We're going to need that because when we have fractions inside our equations, we're going to need a common denominator, okay? And so if I have three numbers like they have there, 12, 15, and 24, when I was finding the greatest common factor, I did the little factor tree or the upside down thing. Okay, you like the tree better? Okay, so we'll do 3 and 4,
and 2 and 2,
and 2 and 2. So the factors for this are 3. Actually, wait, let's just do it this way. We'll just bring down the 3. Okay, so we have them all right there at the bottom. Okay, so for 15, it's just 3 and 5. Okay,
that's a nice one.
And then for 24, it's
6 and 4, or 8 and 3. Yeah.
Which one do you want?
It doesn't really matter to me.
Okay, we'll do 2 and 3, and 2 and 2. So they're all on one level here. Okay, all right. So actually, that might not have been a bad idea. Let's pause this and get that in there. So we found our factors, and so that's what we were supposed to do. I'm going to come over here and we'll look. First thing we're supposed to do is find the prime factors, and then we're going to list them and express them with their exponents. And sometimes you can do the exponents, or you don't have to. Okay. And so now we're going to do list each factor which appears. If common factors have different exponent values, we're going to take the largest amount of them. Okay, so we're going to just list every single thing that's there. Okay. And if there's some in common, we take the most. So, for example...
so like opposite of what we did with the greatest common factor.
Exactly. So I look over here, and I've got a 3, a 3, and a 3.
We want to take the most.
Yeah, and there's 1, 1, and 1, so we take the 3. There's 2 here. There's 2 2s. 2 2s, 3 2s.
Oh, yeah, 3.
And no 2s. And the highest amount of 2s is 3 2s. Mm-hmm. Okay? And we have no 5, a 5, and no 5. And we take the most of them.
So it's 5.
So it's 5. Okay?
That's really going to mess me up.
So it's actually total opposite. The least common multiple, we take the greatest. And the greatest common factor, we take the least. Okay, so it's backwards. And then we just multiply this together. We have 3, and that's 8. 3 times 8 is 20. Let's see. Maybe that's...
No, that's 8.
40. Yeah, let's do it this way. Let's do 8 times 3 is 40. Times 3 is 120. Yeah, that's what I was trying to figure out which one I should do in order. Because for me, I don't know what 24 times 5 is as much as I know the other one. Yeah. So 120 would be on my least common multiple, which would be my common denominator for all 3 of those.
Is that all you have to do?
That's all we have to do to know how to do the least common multiple.
Oh. I was like,
and so we'll need to know that to do the other things. And sometimes it's easy to see the common denominators. For example, this one. It looks ugly at first. We're going to do it... we're going to do 5x over 6 minus 4 equals x over 3. This looks really ugly. You'd think we might add 4 to both sides, but this is a fraction that we're adding, and it's going to have fraction plus that, and it's going to be ugly. So what we're going to do is try to get rid of the fraction so it won't be ugly. And we're going to do that by finding the common denominator, okay? And the common denominator of 6 and 3...
There's 2.
No.
3.
It's what we both go into, not what they can be reduced to.
Oh, they can both go well. They can go into a lot. They can both go into 12.
They can. We want
or 6.
Or 6. Yes. So, and that's how they can go into 6 and 12 and 24 and 18 and tons and tons and tons and tons. But we want the least common multiple of them all. Okay. So they both go into 6. So we're going to multiply by 6 on everything. So it's almost like we're going to do a distributive property right here, but I'm actually going to distribute the 6. I'm going to put the 6 right here. I'm going to put the 6 right there. We're multiplying, by the way. And I'm going to put it here because I can't fit it in between there. Okay, so we're multiplying 6 by everything.
So 30x.
And yeah, it would. I'm going to actually change colors here so we can see, because we're going to kind of reduce this. Mm-hmm. Since we could write this as 30x over 6, and that would reduce, right? But we can reduce before we multiply instead of after. These 6's will reduce out. okay? And this was just the 5x. This
But I
one,
thought we had to multiply.
ooh, okay. If we did multiply, we'd have 30x over 6. And this 30 divided by 6 would be 5, right? And so we could reduce first and not have to multiply and then reduce. Okay, it's actually, I think, easier to reduce first.
Okay.
Did that make sense? Okay. So then we have our 5x here. These just multiply together.
So negative 24.
Very good. And this 3 and 6 reduce. 3 goes in twice.
So 2x.
And I have a 2x. Isn't that much prettier than we had before? Okay, so this is our...
Let's put the x.
Thank you. Let's go back to our color. Okay, thank you. So now this is what we had before. We got to get this 5x and 2x together.
Oh, okay. So then we just bring it over.
Yes. Which one do you want to bring over, the 2 or the 5?
The 2.
And why?
Because it's going to be negative either way.
So if I bring this over, I'll have a 0 on this side.
And then you'll have a
3x minus 24 on
Right.
this side. Now what do we do?
And then you just... Oh, right. Plus 24 and plus
Okay.
24, so then you have 24 over here.
Okay.
Divide by 3, which would be x equals 8.
X equals 8. Yes. I want to do something real quick. I want to bring this over here. And I want to show you something also. Okay. If I would have had this, and if we would have done it, instead of you moving the 2 over here and the 24 over there, we could have just moved the 5x over here. Had negative 24, but it's negative, and you might not like negatives. Negative 3x. Divide by that negative 3. Less steps, but we have yucky negatives.
Yeah, I don't like negatives.
So if you don't like the negatives, do it this way. If you like to do things shorter, do it that way.
I like shorter, but I don't like negatives.
Okay,
so I'd rather do
you
longer.
hate negatives more than you hate long problems. So
Yeah.
okay, that works for me. All right. So let me just recap what we did here so you understand. We started off with an ugly fraction, okay? And so we looked at this fraction and we said, what's the common denominator of 6 and 3? We multiplied every single thing by that common denominator. Not just the things that had fractions, but everything. The common mistake that students make is they'll multiply these, the fractions, but they will forget to multiply those extra things, okay? So when we did that, it became as beautiful as algebra can get in some people's minds. It's not really pretty, but it's better than it was. And now we can solve it and get our answer.
This isn't hard.
Good. Let's do another one.
So this is really all it is?
Yes, we're going to do now with some decimals.
Oh.
Okay, and these are even better. Okay, these aren't as bad. 0.02m minus 1.5 equals 68.5. And before we go into this, I'm going to go one slide over. And if I have 16 and I multiply by 10, what does it become?
160.
160. What if I had 1.6 times 10?
10.6? No.
We just moved the decimal over, so it'll be 16. Just like we had here, moving that decimal over, okay? What if I had 2.57 times 10?
Just move it over so it'd be 25.7.
Yes, 25.7. What if I had 37.62 and I wanted to, no, not equals. And I wanted to move the decimal over so that it no longer had a decimal, so it move it over here.
You do it.
What would I multiply by to make that happen?
By 100.
Yes, because 2 zeros moves it over 2 places, right?
Right.
Okay, that's the essence of this, okay? We do not want,
But we're not multiplying by 10.
we don't want any decimals anywhere. We want them to be pretty and beautiful like this one was pretty and beautiful. Like this one was pretty and beautiful after we multiplied all that out.
Right.
Okay? So, to get this one beautiful, I'd have to multiply by 100. To get this one beautiful, I'd have to multiply by 10. And to make this one beautiful, I multiply by 10.
Oh.
We pick the highest one. We can't multiply some by one thing and others by another because that balance Remember, you have to multiply both sides and everything by the same thing to keep it balanced. So do I multiply by 100 or do I multiply by 10?
100.
We do. So if I multiplied this, we're going to multiply them all by 100. So I'm going to make this teeny little 100 if you want. And this teeny little 100, meaning we're multiplying, okay? We're moving the decimal 2 places. So if I move this one 2 places, what does this become?
2.
2m. Very good. But this one, what does it become when I multiply that?
150.
Yes. And this one?
6,850.
Yes. And now we just solve this like we solved before, okay?
So then, plus 150.
Yes.
So that makes 6,900. No, 7,000. Where did I get 6,900?
Okay.
And then divide by 2. And I have no idea what.
Yes, and that would be fine. What's half of 7?
3.5.
So what's half of 7,000?
35? Or not 35. Wow. 300. No. 3,500.
Very good. Now, I don't know how your homework's going to look, but if you, I don't know, I'm imagining they're all going to be here we go. Let's read this box here. When not using a calculator, your work will be easier when remembering that multiplying by powers and 10 require only moving the decimal point. So, if you didn't want to use a calculator to do all this, moving the decimal makes it beautiful looking, okay? But if you didn't care about making it beautiful, if you just wanted to use a calculator, you could just add that over here and divide that over here with your calculator.
That doesn't sound fun.
Yeah, so if I did, let's do this. Move it over. We'll copy it. All right, if I started with this one, and instead of multiplying by these tens and hundreds up here, in that case was all hundreds, if I didn't care and I just come over and I get my calculator and I say add 1.5, add 1.5, I would just do it on my calculator and I wouldn't care if it looked pretty, and I just have that one less step. So, but if you're wanting to not use your calculator, multiplying by the 100 is going to make it prettier and easier and faster. Okay, we'll do it that way. Let's do one problem of each kind. I don't think so. I think you're going to be all right with it. Let's do one from each kind. Let's do this first one. X minus 1/4 equals x over 4 minus 1. What's the common denominator? You do? What's the common denominator of 4 and 4? 4. No problem. So I'm going to just multiply everything. I'm going to put this teeny little 4 up here. My 4 here and here. I'm going to put in a dot so it looks like I'm multiplying. And then 4 here. That's the key, is to always multiply by everything, even the numbers even the ones that are not fractions.
Right.
When I do a 4 times an x, it becomes 4x. What happens to this one?
It just becomes 4.
Yeah. Well, the 4s, what do they happen to them?
Cross out.
They cross out. What is it left with?
1.
Yes. And these 4s cancel out.
So it leaves you just with x.
For just x minus what comes here?
4.
Very good. That was the mistake that somebody's going to make. All right, how do I solve this?
And now you've got to bring the x over,
Okay, so we're going to subtract the x.
which will make 3x minus 1 equals negative 4. Then you're going to add 1, my bad. So that'll make that negative 3.
Good.
And then divide by 3. That'll be 1. Negative 1.
Negative 1. Very good. Very good. All right, so the key, the new thing from today, this stuff you've been doing all along. It's just that now, multiplying that up the top, okay? All right, so let's do one with a decimal. 0.42x equals 1 minus 0.08x. Okay, so what do I have to multiply that by to get the no decimal out of there?
100.
What about this one?
100. No,
Yes.
1,000.
No, you're right. You were right.
100?
If I move it over 1, 2, it'll be, yeah, it's 100. So we're going to multiply by 100. I like putting that up there so I'll remember. All right, that 100 makes this become what?
42.
Okay.
X.
Uh-huh.
And then 10? No. No. You bring it over to...
Or I just have 100 times 1.
Oh. So it'd just be 100.
Very good. Minus
8x.
yes. Very good. So
And then you bring this. No, just bring that one over.
you want the 42 over here?
Yeah.
Or the 8 over here?
And the 42 over here.
Okay. So how do I bring the 42 over?
Plus 42. No, minus 42x.
Okay. So what will be over here?
No, it needs to be plus 42x.
But if we plus 42, we'll have 82 over here.
Oh! So I need to bring the 8x
Yes,
over.
very good. You need to bring the 8x over. All right, so we're going to add the 8x. And what do we get when we do that?
50x
Very good.
equals 100. And so then divide by 50 on both sides. X equals 2.
Very good. There we go.
Yeah, it's
Beautiful.
not bad.
Not bad. I think you're going to like it.
Mm-hmm.
Okay. So we're finished. We multiplied. We solved equations with the fractions and decimals.